So let's start last part of first lecture about property of materials. When a builder, architect or engineer specify a material, he or she is really specifying a property or combination of property. Materials are used for the properties that they possess, whether it be compressive strength, thermal insulation, high electrical conductivity, appearance, low cost, or whatever. The property that materials possess derive from their structure. So the way that they component atoms and molecules are put together. Here you can see some property of materials. For example, transparent, bendy, rigid, soft, and hard. It's worth bearing in mind that when we use a material, as was pointed out earlier, we are really making use of its properties. For this reason, it will be a valuable exercise to look next at the process of selecting materials. This is not something usually covered in some books on construction materials. The topic has rather been the subject of text produced for engineers. Very useful to take a preliminary look at the range of properties we have at our disposal, and it's illuminating to consider properties by materials classes such as ceramics, metal, polymers, and composites. Such is the very wide ranges of property values that the values have to be plotted on a logarithmic scale. Here you can compare value of yield strength for ceramic, for metallic, polymeric, and composite materials. We can immediately see that ceramics have very much higher strength than polymer, while metal have a much wider range of strengths from alloy steels down to some very soft, pure metals. Bar chart of data for yield strength. Similar wide variations are seen for stiffness value in this figure and for density in this figure. So note the very wide variation in properties shown in figure on yield strength. The strength covers 6 order of magnitude, and the highest value diamond is nearly 1 million times stronger than the lowest formed polymer. Diamond and formed polymer. In figure, again, note the wide variation in stiffness values, with the data spanning 6 order of magnitude. The stiffness material, diamond also, is 1,000,000 times stiffer than the least stiff materials, formed polymers. When we see on the figure for density, and density value shows that span 3 order of magnitude with the densest metals platinum and tungsten being about 1,000 times more dense than the lightest form polymer. So, behavior of material in service. We shall consider the combination under which materials serve in buildings, including the loading to which they are subjected and the environmental influences which surround them. This is very important because we need to be as economical with materials which are precious resources as we can. In service, we are nearly always concerned with the durability of our materials. Unlike motor vehicles, which have a life of perhaps a decade, buildings are usually expected to last considerably longer, and massive repair and maintenance costs are not welcome to those who are responsible for them. Durability is a term used to describe the robustness of materials in the face of the service conditions that they under. In simple terms, how long they last. And also very important that we need to appreciate the environmental conditions in which the materials serve, as well as the type of events they may encounter or endure during their service lives. In the first place, buildings stand apparently doing nothing and are subject to the elements of the weather and local meteorological conditions on a day-to-day basis. This includes variation in temperature, precipitation and humidity and wind conditions. If the building is in an urban locations, vibrations from vehicular traffic may be a factor, and the temperature may fall below zero from time to time. And this can pose serious problem if weather has been absorbed into cracks in structures or into individual materials, or on frozen water undergoes a 9% volume increase, and this can cause stressing and cracking of those materials which are inherently brittle. This fact raises another very important factor in material performance, and that is the subject of porosity in material. Some materials are porous, such as clay, bricks, concrete, and timber. So, other are fully dense and impermeable to water. Such materials include metals, sheet plastic, glasses, and the porosity will determine whether water will be absorbed by materials during service or not. And porosity will also be a determinant of the mechanical properties of materials, as we shall see. The phenomenon of capillarity means that porous material can absorb water when they are exposed to it, and also tend to retain it even when the surplus water has drained from their surface. And the water doesn't always have to be in liquid form. Porous materials containing moisture will equilibrate with their surroundings and absorb moisture from the atmosphere during time when the weather is wet or humid. Similarly, they will then dry out when the weather is dry or less humid. This effect causes expansion and contraction effects, in addition to those caused by temperature variation. Another factor that is sometimes overlooked is that also buildings are static structures, and they are always under stress. A very large building will possess an enormous weight, and this load is carried by the structural element and foundation. So, if the stress vary in a cyclical way with time, they can lead to fatigue in metallic structural elements. Such conditions can occur in bridge structure, and several historically famous bridge failures have occurred because of fatigue. In addition to this routine environmental variation, we must also consider other events such as fire, explosions, and of course, earthquake. And now we consider the use of materials and their impact on the environment. Because at least 3/4 of the materials used on planet Earth go into buildings and infrastructure, and because this is such a high quantity, the manufacture, use and disposal of building materials has an enormous impact on our environment. The consequence of their use include energy consumption, pollution effect in air, water and soil, depletion of landscape, resource depletion, etc. On a correspondingly large scale, unless energetic steps are taken to minimize and mitigate this effect. There is a real danger that we shall leave a degraded world to our successors and descendants rather than one enhanced for its occupants. And this here you can see a life cycle inventory from cradle to gate. Inputs raw material resources and energy resources, and outputs air emissions, water emissions, and solid waste. So production of quicklime hydrated lime, then transportation, and then waste water treatment, and usage include building construction also, iron and steel other uses. And then we can also use old materials like reuse, recycling and disposal at the end of the life of construction, building and structural element. The impact of the use of material can have several consequences. For example, extraction of raw materials can lead to spoiling of the landscape. The production process can give rise to the emission of dust and gases into the atmosphere, as well as waste liquids and other solids. We need ways of measuring or quantifying these effects if we are to control this unpleasant impact. Unfortunately, the word sustainable is now very widely used and not always by people who understand what it might mean. In the serious academic community, its meaning is still being debated and clarified, and this topic will be dealt with in the final lection of our course. So, concept review. We understand that construction materials are in the main inexpensive and low-tech. Explain why they are considered to be so important in the world of the 21st century. Why are steel and concrete two of the most important materials of construction? And describe the major materials used in the construction and their destination. Thank you. And glossary. Building materials, environment, concrete, metal, steel, timber, insulation material, polymers, clay, glass, gypsum, and bitumen. So you understand all these words. And the next: transparent, bendy, rigid, soft, hard, liquefied. So, bye. Have a good day.